Good morning. My name is So first and foremost, I have to congratulate Computer Science Department has sponsored ICS National Seminar on current growing trends in artificial intelligence smart working system. And thank to Ambedkar and thank to Dr. Krishnamurthy and Computer Science Department faculty members inviting me as a resource person for ICS sponsored seminar. And also, I thank to my university, graduate with University Management and the academic department of Computer Science for allowing me to contribute my topic to Computer Science Department students. So, I'm going to share the topic of Internet working system using queuing internet with bulk service and network security. Introduction. It's a research oriented. Actually, the topic is only research oriented, and it will be a very interesting part of you. I hope you will listen properly, I guess. Right. See the communication. Hello. Right. The problem definitions, the communication across the network, the behavior of the network, optimizing the system performance, monitoring network traffic, and resource utilization. So first we have focused on the objective of the resource work in the internet reporting system. So we have to find the communication, that means the transformation between the systems. So the people who are living in the foreign countries, they have to go the polling. Under this consideration, so they through online they have to poll. So while you are transferring the polling from one system to the other system, what is the arrival time? Because we are the client and the server will be there in the middle way. In the part of the middle way, the server is occupied. So by the time the packets are polling, many people are living in the foreign countries. So they are unable to come to our places, to our country and polling for us. Instead, so they can put polling through internet. So many people can send the packets from one system to the another system. Packet since all the data will be stored in the packet. So it will be traversing from one system to the another system through internet. So at the time, what is the arrival time, the packet's arrival time from the client to the server machine? Even though my dear students, in your computer science lab, so the server and the client machines. So you are all the clients, you are requesting to the server machine. So we want to work under the end program language. So at the time you are requesting to the server machine, file server machine. So the server will search. So what you requested from your client machine, immediately it will go and search that particular programming language. If it is available in the disk, memory disk, and immediately it will be a response to your client machine. These are all happening over here. At the time you can see the 100 students are requesting to the simultaneously to the server machine what will be happening. All the packets will be traversed to the server machine. So one by one it will be request and response. So same as it is while we are polling from foreign country to the our country, right? At the time, what is the arrival time the packets to the server machine? What is the arrival time? And expected waiting time. The server will wait, so the expected waiting time from the clients and the expected busy period because many people are polling, okay, from foreign countries. At the time, the expected busy period because it will be very busy. The server will be busy. Immediately, it won't acknowledge to the client machine. So, for successfully completed, if you enter any data, for example, through online applications, you are entering the data for admission purpose. you online. So what will be after you entered your data, immediately it will be completed, successfully completed your immediately acknowledged will come to your system. The similar same as it is here also after complete your coding, everything will come over there in the system part of view. So for this purpose, what method we have to follow? What method? So whether you heard or not, Markov algorithm. So Markov algorithm in this part of the research. So we have used this Markov algorithm. Why did we develop an internet coding application? Second point. And third one is the queuing mechanism. I'll come to the later queuing mechanism. And novel encryption mechanism for security. See, why we are using the security? Any third party can hack and crack your information. For that, we need a security. How we did, we will discuss later. Now, what are the methodologies supposed to follow? So here the first point is wired and wireless networking using Markov algorithm. Performance analysis. The performance analysis using encryption and novel encryption control mechanism for wired and wireless network. First one, the performance analysis of network devices using algorithm model. Right. The basic network concept. So all of you know the basic network concept in a wired technology and wireless technology. All of you know you are final year or second year student. Second year. Computer network you are studying. Computer network paper. Right. See, okay. In your computer lab itself, you can see mainly in my period ago, mainly in the computer science lab, the two devices are using. One is the hub devices and another one is the switch devices. So what is the hub and the switch devices? For transmit the data from one system to the multiple system. Okay, so hub one input and 14 output. For switch, one input, one output, and one input 14 systems we can connect it to the port. Okay, one system. See, listen, one system connected to the switch or hub devices, that is a wired technology, and connected to the multiple client system. For that purpose, we are utilizing this hub and switch devices. And similarly, wireless devices, we bring technology. Now, so recently was launched the Wi-Fi technology, Wi-Fi and wireless. So these are all coming under the wireless. So for any, if you, through wireless network, we can pole for pole. Okay. See, Wi-Fi technology is nothing but baby Bluetooth. It's nothing but baby Bluetooth. All of you know Bluetooth concept. So in our smartphones as well as in any electronic gadgets, you can see the Bluetooth option. So what purpose we are using this Bluetooth option for transferring the data from one system to the other system purpose. So fine, you want to transfer any file, okay, you can transfer using this Bluetooth. But similarly, in a Bluetooth concept, it would be covered up to 100 meters. Sorry, 10 meters. 10 meters. Bluetooth, it would be covered up to 10 meters. If you use the Wi-Fi technology, it's another name for Wi-Fi technology is the baby Bluetooth. So it will be covered up to 100 meters. But if you want Bluetooth to cover up to 100 meters in a sense, what's supposed to do from our side is we have to use optional amplifier. If you use optional amplifier in the Bluetooth devices, it will be covered up to 100 meters. So without using the optional amplifier, we can use the Wi-Fi technology. It will be covered up to 100 meters. Similarly, Wi-Fi, all of you know 500 meters and Wi-Max up to 2 kilometers. We can utilize this Wi-Max technologies. The model, the client server model. So we know that the internet connection through the router, the server machine connected to the client machine. This is the general block diagram. The internet connected to the server machine, and server machine is connected to the client machines. And similarly, next point. Now we are going to analysis of various wired and wireless technology. See, we know the technology. We are connected we are connecting with wireless technology like wired hub and switch and wireless Wi-Fi, WiMAX, and as well as the Vibri technology. In what way we have to connect it to this part of the systems? So there will be some program and technology to connect it between the systems. See my students, we know laptop configurations, i3 processor, i5 processor, Intel processor, all of you know. One real example I want to share it. So in this Intel i3 processor, Intel i5 processor, i7, i9, okay, all of you know. So in i3 processor, now the Windows 11 inbuilt operating systems are there, but it won't work properly. It won't work. So the i3 processor, but Windows 11 inbuilt, but it won't work properly because the configurations of the Windows 11 is high compared to the i3 processor. It will be difficult to scroll. If it is difficult to move to the one tab to the next tab, for example, Gmail. I open the Gmail. You want to open your college website. It will take time. But in the market, they are using this Windows 11 operating system in i3 processor. If it is i5, Intel i5 processor in the sense, you can operate Windows 11 very fast. Then what we have to do it in an i3 processor. If you have an i3 Intel processor, better you switch to Windows 8 or Windows 9 or Windows 10. That's a configuration. You know, that's a configuration for each and every Intel processor. But maybe you can use the Intel i3 processor Windows 11 operating systems, but it will be difficult to scroll and difficult to open the next tab. So better you avoid. Similarly, the same as it is how we are going to configure with the wired and wireless technology, you'll see now. Okay, introductions. In this topic, the performance of wired and wireless technologies, introductions are the network interface devices, that means transferring the data packet from one system to the other system. Transferring your polling coding systems from one system to the other system through devices, fixed devices, the network devices. What are the network devices? Wired devices and wireless devices. Alright? And performance of the devices, mathematical model under the Markovian model. So we have to rectify. So what is the arrival rate? What is the transfer rate? What is the expected busy period? That means transfer rate, arrival rate of your packet. So you are in USA, you want to poll to our India country constitution. At the time, what is the arrival rate from USA to India? We have to find it. And the expected waiting results, expected waiting time, these are all very, very important. So the polling period 6 o'clock over, up to 6 p.m. only. So before the 6 p.m. Arrival rate, the expected waiting time is delay in the sense we are losing. We are losing, the users are losing our polling. Okay. So that how we have to evaluate, how to calculate all those things by using the arrival time, expected waiting time, everything by using this Markovian algorithm. Okay, you want to find which one is the efficiency. Which one is efficiency in the sense hub? Okay, I'm asking question to all of you. Which one is the best efficiency, hub or switch? In your computer science lab, the systems are connected through hub or in switch port. Which one is speed? Which one is the speed? No idea? So compared to hub, switch is high speed. Okay. So directly connected to the switch from the each and every system. But hub it will be shared to each and every system. It will be take time to reach the client machine. The packets are delayed compared to the hub. So how you are telling, sir? How you are calculated using this Markovian algorithm? Using this Markovian algorithm, which one is the best efficiency for transferring the data from the server machine to the client machine? Alright. Yes, using this Markovian algorithm, formula is m/1. Markovian model. M is nothing but m/n is nothing but Markovian model. A, B/1. Single server. Using single server, multiple arrival. That is the meaning. A, B/1 is the single server. Using the single server, multiple arrival will come. Multiple. You are all the multiple arrival. Okay, multiple. You are requesting simultaneously to the systems. What will be happen? Traffic.
there will be a congestion to reach the server machine. Okay, for that purpose, what we have to do, I will tell you. Okay, in this bulk service role, the Neon is a 1967 is one of the research author introduced the general bulk service role. He only the person is introduced this bulk service not going under the rule. As per the rule, the service starts service only with the minimum batch time, a number of customers are waiting in the queue, and the maximum capacity is B. That is the A comma B, what I have mentioned in the bracket, that is the meaning about this. A is the batch size, number of customers, number of clients, okay, and waiting in the queue, and the maximum capacity is B. Right. See, the maximum capacity, so far here 200 people are sitting around. Initially, it starts from 0 or 1, and maximum it will goes to up to 100 or 200. Okay. And the objective of this rule is to study the waiting time distributions of such a bulk service system under the steady state. What are the parameters to find this variation in between wired and wireless technology? We have to find, first we have to, once we are going to deploy, once the project is going to deploy, or else you are doing some programming languages. So how we are going to deploy? For example, quadratic equation. Under the quadratic equations, the roots are real, roots are imaginary, you have to find the categories, right? So how we are going to do? The four phases are very important. So the teachers are given a question, quadratic equation. Solve the quadratic equation using C programming language. So how we are going to deploy? How you are going to deploy and what concept you have to utilize? The four phases are very important. Analyze. First you have to analyze. After analyzing, what you have to do? Next point is design phase. And third one is the coding phase. And fourth one is the testing phase. And there will be 7 phases: modification, verification, and implementation. See, using these 7 phases, you are going to find the program what questions you have received from the faculty member. So, quadratic equation, you have to analyze. What you are going to analyze? Formula. Logic, you have to analyze it. What functions you are supposed to use in this part of the quadratic equation. So, to find the roots of imaginary, what logic you have to use. To find roots of real, what logic you have to use. So, after using the logic only, you will get a solution. You will get the execution part of it, or else you won't get the solution. Similarly, the same as it is, if you want to find the speed, arrival rate, the packets, the packet is nothing. What's your data is inside the packet, the internet porting, right? It will be travels from one system to the other system. At the time, we have to find the speed, arrival rate. So 10 Mbps, 150 Mbps, internet speed, all of you know, right? The similar same as it is, the bandwidth of the internet, the frequency of the internet, the speed of the internet, how we are calculating. There is some technologies. Same as it is for this voting system, internet voting systems. So with the help of the devices, without the devices we can't. Sir, we are having a Wi-Fi. We need internet access facilities. Without internet access facilities, we can't do it. So in your college, you are having an internet. Wi-Fi connection is available. How you are going to access? There will be a username and password separately. You have to access the internet through our college. Instead of your mobile data, please note the point. Instead of your mobile data, so if you want to access the Wi-Fi internet connection through Thiruthangal Nadar College, how you are going to access? Is there any option? No option. So if you are providing the internet access through your system, laptop systems, or else your mobile system, so there will be a separate configuration. Your system administrator will configure your laptop as well as your mobile phone to access internet, or else we can't access. We, the faculty members who are all working here in the college, they can access the internet. They can access an internet. Similarly, the same as it is, that arrival time, the packet's arrival time, there will be a speed. Now, compare with your mobile data speed, Wi-Fi speed is heavy. Why? Because the bandwidth, frequency bandwidth, very high compared to your mobile data. Got it now? Same as it is for voting system also. What arrival of the packet, inter-arrival time and inter-service time, and that means it's the time taken between server and client. That is response. Inter-arrival time is the between client and the server. That is request. The client is request to the server, and server is respond to the client. But all of you know this general. And root of specification, we have to fix the root of specification, that means the threshold value. So up to 0 to 1, in between 0 to 1, we have to fix up the value. We will see now. Here, the probability in the server is idle, the formula is given, it's a high system, and n units are in the system, waiting time density, expected waiting time density, these are all parameters. To find the parameter, okay, to find the solution, we need this parameter. To find the matrix multiplication, we need a parameter. To find the NCR value, we need a parameter. To find Fibonacci series, we need a parameter. We are calculating right using the logic. Similarly, the same as it is, we are having such a parameters to calculate. Okay. For example, this is the study results. So what we had discussed, the first slide, the wired technology as well as the wireless technology. So now you see using this Markovian algorithm for voting system, using the Markovian algorithm voting systems, the inter-arrival time, roots of specifications, and request and response, we are compared with the M1 M/1 1, B/1. So we are compared with the two algorithms. Which algorithm is efficiency? Because while you are deploying any project, we have to compare with the existing one. All of you know. Okay, we the faculty member did PhD, doctorate. Okay, what we will do? Compare with the existing papers, existing research paper. We'll go through each and every papers and we will get an idea for proposal for new one. All of you understand my communication. You need Tamil also. Which one you want? Tamil. Both. Tanglish. All right. Listen. So the technologies you can see this parameter on the left side. Switch, Bluetooth, Wi-Fi, and WebMax. So here, request. Previous slides we had discussed the formula. Okay, that one and new request and response. This is one algorithm and another algorithm. We are comparing with the existing algorithm. Okay, which one is efficiency? So which one is efficiency? We will find the solution. From that algorithm we are going to propose. Not the old one. New one we are going to propose it. Right. See for the hub. Request, you can see this. Request time of the packets. The voting, you voted. Okay, in local, we are unable to go to the polling system, polling voting area. So, sitting in our home, we are sitting in the voting system. What we are doing, the arrival rate, request rate, and response rate 0.06369. Here, the response is 0.35. And similarly, compare with the switch 0.07 and 0.36. And Bluetooth, compared with the hub and switch, you can see the Bluetooth is more efficiency. Compared with the hub switch Bluetooth, Wi-Fi is more efficiency. Compared with the hub switch Bluetooth, that means hybrid technology. Okay, hybrid technology. Wi-Fi and WiMAX. WiMAX will be produce more efficiency compared to other technologies. So, using that parameter, we found the solutions expected. This is the root of specification, expected waiting time, expected busy period. These are all parameters. Using these formulas, we find which one is the efficiency. Now you can see which one is efficiency compared to the hub. Switch is more efficiency. But we should not say switch is faster, better. We should not say better compared to the hub. We should not say. Because hub also have more efficiency and switch also more efficient. We have to say only the efficiency word compared to the which one? Hub. So compared to the WiMAX, compared with the Bluetooth, Wi-Fi, WiMAX is more efficiency in a high-speed level concept. So these are all study results. What we had discussed in the previous slide, Markovian algorithm. So how we are going to poll? Because the people are going to poll. So in what we are going to poll, before going for the polling, we have to study the results. So using the study results, we have to deploy results. We'll see. Why did we develop an internet voting application? Only few countries already Dr. Ambedkar in our internal function, so we have mentioned clearly. So only few countries have so far developed an internet-based voting application. So the evaluating practices and validating technologies has shown that the internet voting is mostly being considered by countries that are already implemented changes in voting method such as placing electronic ballot box in polling stations, introducing postal voting. Already introducing the postal voting is already available. Using the internet as political campaign tool. So how we are going to use the polling electronic ballot boxes and in the polling stations. So now this concept we are going to try placing electronic ballot boxes in polling station. Already we have introduced the postal voting. So any foreign countries through the internet we can vote. In what way we can vote it? What we are going to do this? You'll see now. The versatile nature of e-voting, that is, e-voting is nothing but electronic voting. Internet voting shares with postal voting the characteristics of being a remote ballot box because it is dematerialized. It is totally different technically and legally from no voting methods. And similarly, another challenge. What is that another challenge? Is take social and legal context into account when developing the electronic application point of view. You can see this model. The possible scheme of this model is so through internet voting, one wants, for example, to be able to run the application in a different configurations of the hardware as well as the software specifications, and forming also the home the ballot box with the different softwares. So this is the server machine. The last possibility will be the best. One is the case of those on the ballot counting and doing the decounting with the same tool will always give the same results. So these are the methods using this Excel sheet or Internet Explorer or any machines like Google Chrome or Mozilla Firefox and Internet Explorer. You can send out voting to the packets to this particular server machine. So this is one of the block diagram for the same. You can understand very easily this block diagram. So the system structure for the electronic voting ballot system. So here the first server runs on Microsoft because not only the Windows operating system, we have more operating systems like Ubuntu operating systems, Windows operating systems, Linux operating systems, Mac operating systems, okay, BlackBerry operating system. Likewise, many operating systems are there. Whether all the operating systems will configure one key operating systems or not. Of course, it should be configured. It should be working, right? Even though your college website is working in all operating systems, right? Through your mobile phone, you can see your website. Through your laptop, Windows operating system, all versions of the Windows operating systems, you can see your college website. And Mac, that is an Apple Mac operating system, you can see your website. Or while you are developing any website, while you are developing any app, that should be configured for all types of operating system. It's the same as it is. Through the Microsoft, through the Linux OS, any OS can be transferred from the one to the another system through internet. Through internet, we are going to code. The performance analysis queuing networks. Okay. In queuing networks, volume, that means the number of packets. The number of packets will be a huge volume of data. Each application depends on some servers. The technical mechanism in each of such devices varies. And similarly, the performance of each device can be analyzed and make it efficient manner. Queuing theory. In this part of the mathematical study of waiting lines of queues, the theory enabled mathematical analysis of several related processes. The theory permits the derivations and calculations of several performance measures. Which one? That is a Markovian algorithm theory. So, understanding the Markovian algorithm, we compared with the existing algorithm and the proposal algorithm also is true. We found the best results. So that I mentioned clearly the parameter wise. That is up. Which one is the efficiency compared with the upper switch is more efficiency in wired technology. Wireless technology like between Wi-Fi and WiMAX is more efficient compared with the between technology, Bluetooth technology as well as the Wi-Fi technology. So these are the study results and how we did all those things. So we know the queuing network connections in between the client and the server machines. So the connecting arrival request. So the big area CPU1 and CPU2, that is a file server or system server, whatever it may be. So we are sending this arrival request and place 1 and place 2 to the memory disk. So this is the general diagram about the arrival rate and request rate between the client and the server machines. Okay. Now we come to the queuing pettinet. So queuing pettinet is one of the wonderful tool. Wonderful tool in the sense how you are saying, sir. Sir, 200 people simultaneously are requesting to the server. Simultaneously you are requesting. All packets are arrival in front of the server machine. So delay, it will be the latency of time, it take time. You won't get properly response from the server machine due to traffic. Like principal said, the toll booth. So finally, all vehicles are overtaking each and every vehicle. What will be happen? Finally, you reach the toll booth, you have to stand on queue. One by one, only they will release the vehicle. All of you know the concept. Same concept in this queuing pettinet too. So in this queuing pettinet, if you connected in our lab, in our computer science lab, if you connect the queuing pettinet tool, all the people are simultaneously recording the same programming app through the server machine. From the server machine, you are requesting. Sorry. So what will be happen? The arrival packets, you are all the client people that are sending the request. It will be stored in the packet. That packet will be goes to the server machine. So it will stand in front of the server machine. Bulk packets are arriving. So how it is going to manage? How the server is going to manage? Immediately the server will be response to the client person. It will take time. You will get acknowledged from the server machine, but it will be take time. Or else sometimes your packet will be congested or traffic or what will happen? Crack. Maybe it will be cracked. Once again you have to request it. So these are not happening. If you connect this queuing pettinet tool, it won't happen. Because there will be two categories. One is place, another one is the transition. The places in queuing, but I will come to the point. Place typically represent condition with the system being modeled. The transition represent event occurring in the system that may cause change in the condition of the system. Or connect places to transitions and the transition to place never end or from place to place or from transition to the transition. So this red color circle is nothing but place. And rectangle box is called as a transition. Red color circle is a place and a rectangle box is a transition. What is place and what is transition, sir? So place, what will happen now? In front of the client machine and the server machine, the place tool will have to be fixed. What will happen, bro? That packets are arriving right from the client machine to the server machine. So the packets will be deposited in the place option. The packets are all deposited. The transition nothing but in between the two places, in between that is the client and the server machine, we are fixing this tool, right? Place tool in between the transition device and right hand side another place. So the place we will fix in the client machine as well as in the server machine. In between these two, we are having a transition device. Transition devices means what? What are the transition devices? Just now we had discussed wired and wireless technologies. So that is the transition devices. Wired is nothing, hub and switch. Wireless is Vibri, that is a Bluetooth, Wi-Fi and WiMAX. So we are connecting through Wi-Fi. You can send the request. Through Bluetooth, you can send the request to the server. Through WiMAX, you can send the request to the server machine. Got it now? Clear, all of you? Is it clear? So while you fix this queuing pettinet, what will happen? So what happened? All the request packets are placed, that is deposited in a place. One by one, it will release. So what will happen? Immediately the server can acknowledge very fast to the client people. Hope you understand. We will see now. Queuing pettinet parameters. What are the parameters for this? The packet arrives in queue, the packet arrival is in the queue, and packets are deposited. The packets are deposited in through wired or wireless devices to the server machine. So there will be a two machine, one is the client and the server. In between the server machine and the client machine, we will fix the tool, queuing pertinent tool. The tools are nothing but one is placed, another one is the transition devices. Transition devices is nothing but we want to transfer the packet from one system to the other system using this transition devices. One is wired and another one is wireless technologies. Okay, in this, the related work, okay. What happened? No, we compare with the existing one. We compare with the existing one. Mr. Louis Alexander Otis in the year of 2001, what he did in an aspect sense relating to the pertinent diagram, the transition of pertinent may fire whenever there are sufficient tokens at the start of all input. Okay. The Louis Alexander, what he did know? For example, in Thiruthangal Nadar College, even HODs want separate cars available. For example, I'm telling for HOD. So three department: Commerce department, Computer Science department, Software System department. 3 or 4 HODs along with one driver. Along with one driver, car driver. So after 4:30, the college timing will be over, right? 4:30. So the car is waiting for how many HODs? 4 HOD. Right? Clear all of you what I'm saying? 4 HOD. So 3 HODs are came and sat inside the car. 1 HOD is pending, not come. Still the driver will wait or he will start the car. What's your answer? He will wait, right? So the same as it is, one packet, if it is any packets come only, it will start the process, or else it won't start. So the people, for example, the packets, 10 packets want to deposit. Only 9 packets are available. One more packet is pending. Until it will wait, it won't process. After arriving at another packet only, then it will be processed. It will take time or not? Time or not? Okay. Right, I will show this slide. See now. These are all called phase. These are all called phase. This one is the transition devices. This one is the phase. So total 6 phases are available. These are all client and this is server. Okay. So what happens in the phase 1, we are having 7 packets. In phase 2, we are having 5 packets. 3, 3, 8, and similarly 4 packets 4 and 3, 5 is 9 packets. So 2 arrival. If it is 2 arrival only, it will be processed, or else it won't process. P is nothing but the transition. Similarly, all voting, we are not depositing all the voting packets from foreign countries. The people are voting, okay, through internet, the people are voting, the packets are all deposited, the voting packets are all deposited. But using the transition devices, we want to send all the packets to the server machine to store all the packets in the server machine. Clear all of you? So 7 vote packet are available in place 1, and the second place 5 vote are available. Third one to 8 vote packets are available, and the fourth one 4 packets are available, and the fifth one 9 packets are available. That means different countries. Please listen. Different countries. Okay, for example, Japan, Australia, Argentina, Ireland, and so our Indian people are living over there. Clear all of you? Our Indian people are living over there. They are sending the electronic voting system. So after arriving all the packets and based in the deposit, then finally they will transfer to the Indian machine, Indian server through internet. Clear all of you? Okay. So here the process is waiting in queue due to insufficient of required token. So that gives illustration this concept, voting system concept. Clear all of you? Use this voting system concept. After arriving the two, if it is arriving the 2 only, it will be possible. Why sir? 1 star, 1 star, 1 star? Because here the previous slide you can see now, said 2 is going on. Next process, 2 if it is 2 means how much it will be there? 5. Here, how much will be there? 3. Here, 6. And it will be go on. Second iteration. Second iteration, how much? Next term. Here, 2 gone already. Okay. 7 minus 2, 5. Then 5 minus 2. 3. 3 minus 2. 1. 1 will be there. See now. Here now. See, after arriving, so total, all the packets are gone and basic 15 electronic voting systems are arrived. From here, only we are going to transfer to the Indian server. It's an existing work, I tell you. Clear all of you? So what happens? Balance one is available. After arriving, see, read this. Process waiting in queue. The car is waiting for one HOD. The car is waiting for one HOD. After arrival from that particular department HOD, the car will start. The same process is happening over here. So why unnecessarily want to wait? Clear all of you? This is existing method, voting system. Now proposed method, we go for the proposed method. So using this proposal to overcome the above limitation where the process waits are held down due to the insufficient programs. And all of mechanism has been proposed in this proposed system. So considering the 5 places, voting 5 countries, for example 5 countries, P1, P2, P3, P4, and P5. Connected to the transition, that is the transition divisor. The total value, the P1, 7 volt is the same, 5 volt is the same, 8 volt is the same, and 4 volt is the same, and 9 volt is the same from different countries. Are you listening? Are you listening? Alright. So the P is a transition, minimum and maximum. Minimum 0 and 2 is the element. And this mechanism has been generated. The final result without any wait process. In previous one method, wait, have to wait. But here, without the waiting process, all the voting packets will be transferred to the Indian server machine. See now. First iteration. Listen all of you. First iteration. Different countries, people are voted. 75, 8, 4, 9 is voted. And minimum 0, maximum is 2. And P6 is waiting. Second iteration. You can see the second iteration. 7 minus 2, 5, 8, 6, 2, and 7. Here. So all the votings are placed in the P6. 10 votes are came. And next iteration. 3, 1, 4, 0, and 5. 20 packets are varied. And fourth iteration 1, 0, 2, 0, 3 is balanced. That also travels to the server machine. And finally 0, 0, 0, P5 is available 1, 1 volt. That also finally travels to the P6. Total 33 votes from the different countries placed in the server machine. From this server machine through internet, we are going to traverse all the 33 packets to the Indian voting server machine. So, the other 3 packets are waiting 45 minutes inside the car. 4 HODs are waiting inside the car. So, driver also waiting. HOD is the person who is not giving the right time. He or she is having to meet the department meeting. So, unable to reach the car, why they want to wait? So immediately have to inform to the concerned HOD, you come by any cab or any vehicle. So we are leaving. Because we have to go. Why unnecessarily want to wait? So that options are available. Immediately what they will do, the other HOD, department HOD, they will inform to the concerned HOD. So we have to leave. Almost we are waiting half an hour. Why supposed to wait? The time allotted for the HOD, 4:30, 4:45, the car will start from college to their houses. Correct. So why unnecessarily want to wait? So they will inform the concerned HOD, come by, drop on your cab or any vehicle facilities that will arranged by police. So that is what will happen. This is only yes. Novel encryption control mechanism. Right, sir. While you are sending all the packets, correct? You are sending your vote through internet. Hackers. There will be some hackers. They can hack your voting informations and crack your information. What is the security? What is the security? There is no security. Whether the packet reached safely to the Indian server, Indian voting machine server or not, how do you know? So for that, we have to fix one security. Now, any third party can hack and track your information from your packet. So what's supposed to do? So there will be some novel mechanism security did in this part of the concern. Cryptography and steganography. You studied, I guess. Not RSA algorithm in computer network. Study. So one concept, cryptography and steganography. These are all existing security mechanism. So in proposed mechanism, what we will do it? Okay, we'll see. Cryptography is nothing. It's a Greek origin, secret writing. The science and the art of transforming messages to make them secure and immune to attacks. So there will be a symmetric key, asymmetric key, and hashing methodology. You can see this block diagram, encryption and decryption model. Here you can see P is nothing but plain text, C is nothing but ciphertext, E is nothing but encryption function, and Z is nothing but decryption. So when you are sending any information to your systems, it happens encrypted and decrypted. You studied about it, right? So this is one of the block diagram. P is nothing but a key. Symmetric key and asymmetric key we learn, right? The key will be provided for this. Nothing but password. Nothing but password. Steganography is nothing but, in a Greek origin, it's a cover writing. We will hide in the image, we will hide the information. In your photo, we will hide the information. Clear all of you what I'm saying? In image, you can hide your information. So the receiving the message itself by coming in something else. The cover as well as message can be text, audio, image, and video to be covered in this steganography. So securely, we want to send the text messages, video, audio, everything through the steganographic concept. Steganographic block diagram. So C is nothing but common object, message information you are sending, and stego key. That is stego object. Object is nothing but image. In any images you can hide your information. Sir, you are sending all the detail, your data through audio, through the text messages, and myself is Thiruthangal from USA. I am sending voting information through your system's address. That is your mail ID you are sending, right? Through this mail ID, we are sending all the voting information full with the secure. All of you know my dear. Previously, in the browsing, you can see in the URL www.gmail.com you are typing, right? HTTP. All of you know HTTP. Now it's coming under the HTTPS. All of you know it. You can check it in your HTTPS. Yes is nothing but secure. Yes is nothing but secure. So your URL website is full secure. I understand. Similarly, the voter will send the information to the steganography or cryptography, either of the information to the object. So apart from this, what is the novel mechanism we can do? Novel encryption. In this novel encryption mechanism, which deals in the message, it transforms into binary image. It transforms into the binary image. Previously, what we did in cryptography, we can hide the information. In steganography, we can hide the information. Any text messages or video or audio can hide it in an object. But apart from this cryptography and steganography, along with the help of the existing model, what is the new novel that added in this e-voting system? In this e-voting system, the novel encryption scheme is very useful. When we transmit the information from client to server and server to client, they don't understand the message because it is available in cipher image like an ECG diagram. All of you know ECG diagram. In a graph, you know graph sheet. Dots are available, right? Dots. So any person can hack your information at the time. While want to read all the information, you can see only dots. You can't read any information. Any hackers can open, but the person cannot read the information because full secure all the information provided with the notes. You'll see. This message, encrypted cyber image, these are all terms. These are all terms. Graphical sheet from graph sheet. It's look like a graph sheet. All the information are hidden in the graph sheet. Each and every plot, all the information is there hidden. All the information for all voted to the concerned constituent layer, we can't read it all those things. So encryption model and decryption model. The comparison table of the cryptography, cryptography and normal encryption method. Cryptography, the parameters are known message passing. What we are sending the message, no. In cryptography, unknown message passing. Unknown message passing in the sense video, audio, text, and hiding in the image and they are sending the information. But normal encryption, same unknown message passing. Similarly, in cryptography, common technology. It's a common technology, symmetric key and asymmetric key we are providing. But cryptography, little known technology. In normal encryption, novel technology will be provided. Here, in cryptography, key needed. We have to send the key. And similar in cryptography also, we need a key. Sir, authorize the person, I will send the key to open, sir. If you want to open my email ID, without knowing my password, you can't open. If I give the key to the concerned person, authorize the person, they can open and submit it. Yesterday, I have to apply this special casual leave today. Fresh request. I forgot to apply. Immediately through my mobile phone, I started to apply. The support document you have to submit. Support document in the sense, the certificate from this college or any photograph like this photograph, brochures you have to submit it. And I'm thinking while I'm traveling by train, I'm thinking how we can submit all those things. I immediately called my colleague. So what I mentioned clearly to him. See, I sent the brochure to your email ID. I'm not giving my email ID. I'm not giving my email ID, username and password to the faculty. Instead, I send the brochure to his mail ID. What you want to do? Apply online application. The application is available in our Christ University. So there is no manual in Christ University. Fully automated. Fully automated through online we are doing all the works. There is no manual work. Even attendance also we don't take in attendance register. Through attendance app only we are taking attendance to the students side. What happened? I immediately sent my brochure to the concerned faculty. Sir, open KP, that is knowledge base software is available. So through that we have to apply. Sir, I don't know your username and password. How can I apply it? I'm thinking over it. So if I give the username password, all full detail, the concerned person can look up. All my secret files, they can see it. So what I do immediately, using my smartphone itself, I apply it. Accepted that brochure, converted into PDF. That PDF accepted in the knowledge base software, and immediately I send this, they authorized and signed fully online. They given a permission to take a seminar with the college today. So likewise, he required. So here there is no required, intrinsic, it is automatically intrinsic. So most algorithms know the government department. Technology is still being developed for certain domains. Here, there is no technology values. We need some person, technology person, in a cybersecurity, or in a government, central government, there is a cybersecurity. The government, most people know the government department, how we are using all those things, we are not really stressed. Here, strong algorithm or currently resistant brute force attack systems. Once directed message is known and detection is impossible. We can detect, but we can't read the information. Who voted for whom? We can't read it. So full secure. And it will be a high expensive computing power required for cracking. Small expensive computing power required for cracking and not possible for cracking in a normal encryption method. Similarly, technology increase reduces the strength-wise. Here also the same technology is the reduced strength, and no technology is available in this normal encryption. Many technologies are there in cryptography and cryptography, RSA algorithm, keyfire algorithm, okay, DES algorithm, AES algorithm, BLS algorithm, many algorithms are available, but there is no algorithm in the novel encryptions. So only text formats are available. Many carrier formats like text, audio, video, almost everything covered in the cryptography. Image, only the image carrier is used here in the novel encryption method. This is one of the block diagram. On the what we have discussed, the Markov algorithm, queuing network, queuing internet, and novel security, everything is involved in this part of the block diagram. Queuing internet through the novel security, and cipher which will be converted to the word development and the server and Markov algorithm can proceed. The same thing, without previous slide, without cipher image graph is a graphical model. It's a secure. These are the information. The dots, the dots are all information hidden in the cipher image. We can't read it. If you want to read, if you want to have this image, you can't read it. You can see only the ECG diagram. That is the graphical diagrams. We can't read this information. So how we have calculated these are the things. For example, the character ASCII code, some product. My name is, I have mentioned, output you will see this. So each and every characters we need an ASCII code. Understand? ASCII number. And in between these are the problems we done that. And finally we get this for A some defined by I is 105, for R is 114, U is 1 something like this. Each and every character will have an ASCII number. Using this we calculate. Same as it is, vice versa. And finally you can see in this constructed image, the cipher image I told, right? Cipher image. So you can see this. So what is this dot, sir? What is this information, sir? What is this information? The person, the third party, right? While the person is hacking this image. So the scene only the graphical dots, the graphical dots. So each and every dot is nothing, my dear. My wife, my son, first son and second son. These dots. Here all of you what I'm saying. Information is nothing but this is the information. My name, my wife's name, my two sons' name provided to you. So we can't give this information. This is the novel encryption while you are voting because the 4 people are voted. Clear all of you. My family members are voted through internet, electronic voting systems. So the person is hacking. Who are the people who voted to this particular campaign? So you can't read. The person can read only the terms. This is one of the novel encryption. Full security while you are voting to the people, any person, right? You are voting from any countries, you can send it to languages. So first, while you are sending the call to detail, the government have to set full security. The government supposed to set security in your systems. No one should not read. See, if you are polling and voting to one person, you will come and inform to everyone, I am voting to this campaign, I am voting to this person. We should not say that it's a highly confidential. We should not share to whom I would vote, to whom I vote. We should not say. The same as it is, what is the security? The people from foreign countries, what is the security? This is the security the government is supposed to alert the system, into the systems, so that who are all transferring the packets from different countries can vote it securely. These are the references. Any questions? So, hope you all understand it. So, a little bit summary I have to tell. While you are going for any voting systems, electronic voting systems, what supposed to do through internet? So, first we have to analyze the devices. Devices in the sense, what are the devices? Wired devices and wireless devices. So, which device is more convenient for us, efficient for us? If it is local, urban switch, local organization, it will be very easy, or Wi-Fi is quite enough. why max in the voting systems, how we can do it, everything we have to analyze it. Analyze what is the arrival rate from foreign countries, the packet arrival rate and the expected waiting time, everything we have to analyze it. After that only we can go for implementation for electronic voting system. Main thing is the queuing internet. Many people are in our foreign countries, different foreign countries. They want to poll through internet. So all the packets are arriving. So there will be sometimes the packet will be cracked. Packet unable to reach the server, Indian server. So what we have to provide it. For that purpose, queuing Petronet tool have to provide it. In the queuing Petronet tool, place and transition two devices are there. In the place, what will happen? All the packets are all deposited, and one by one, the packet will be released to the server machine. And finally, while you are sending the information to the one system to the another system, what is the security for our voting information? So we have to provide one novel encryption security systems. So these four contributions is very, very important while you are going for the electronic voting system. Thank you. Thank you.
Thank you so much, sir. That was taking information. You have explained about the voting system. It's simple words. Thank you. Audience, please wait for